Good. This is worksheet 6. We're back to that nice, comfortable area of stats class. All right, and this is probability, because that's what it says, probability of. Probability of getting the Queen of Hearts. And there's 52 cards in the deck. There's no jokers. There's 52 cards in the deck, and you're only going to get one of them that you're going to be happy with. So, 1 out of 52. Bottom number, everything you got. Top number, the ones you're happy with. Okay, and it's a fraction right now, and I could convert it into a decimal if I really wanted to, because I could get on my calculator and go 1 divided by 52 equals, and then some like tiny little decimal. There's no reason to. You're allowed to leave them as fractions, and this is why I said on the other video, I said I just do whatever's convenient. That's convenient. I'm done with the problem. Why even worry about it anymore? 5 queens in a row, we already did that. It's impossible. There's no way to have a poker hand of 5 queens. Probability of a boy, again, we already did that. That's 1/2 or 0.5. Probability of rolling a 2. So presumably if you're rolling something, it's a die. And it's got 6 sides. And getting a 2, that's the only one you want. That's the only one that you're going to consider to be good enough. So 1 out of the 6 possibilities, that's it. Rolling something less than a 4. It didn't say less than or equal to, it just said less than a 4. Okay, so you mean like rolling a 1, or 2, or 3, but not a 4, 5, or 6. Okay, so less than a 4 is 1, 2, and 3. 3 out of the 6 are going to make me happy. I can leave it as a fraction if I want, but I can't leave it as an unreduced fraction. That's why I went ahead and just changed it into a decimal. I could have written 1/2, but you can't leave it as 3/6. Rolling a number less than 7. Oh, well, okay, we already did this. That's 0. Not going to happen. Okay. Oh, no, rolling a number less than 7. Sorry, I was thinking greater than 7. Less than 7, you mean like a 1, or 2, or 3, or 4, or 5, or 6. Oh, yeah, that'd be pretty much all of them. Okay, 6 out of 6 equals 1. That's what we said. When it's certain, then it's just a 1. It's certain you can get a number less than 7. Rolling a 4 and flipping heads. Okay, well, I wrote out a sample space for you on the problem. It looks really complicated because, oh my God, what's all this extra stuff? What am I supposed to do with that? That's just the sample space. Okay, the coin and the die don't know about each other's existence. One does not affect the other. They just both happen. And all the things that could happen, I just drop them both on the floor, and the coin is either now on heads or tails, and the die is on 1, 2, 3, 4, 5, or 6. So it could be like there's a 1 and a heads on the floor, or it could be heads, but it could be the 2 in the heads, or the 3 in the heads, or the 4 in the heads, or the 5 in the heads, or the 6 in the heads. Or maybe the coin landed tails up, so it'd be 1 and tails, 2 and tails, 3 and tails. That's 12 things. Okay, and now that is just me writing out the sample space, and it's there in the notes and the homework as well, and it looks really confusing, but all it is the sample space. All right, I just have to answer this. 4 and heads. Let's see, that's this one. The numerator is 1 out of the whole reason for writing the sample space so I could count it up. There's 12 things there. 1 out of 12. Okay, now the last one, I got out 2 dice. Okay, and let's say one of them's red and one of them's blue. All right, so when I throw them, if the red one's got a 1 on it and the blue one's got a 2 on it, that would look like this. But if the red one's got a 2 on it and the blue one's got a 1 on it, it would look like that. Okay, having a red 2 and a blue 1 is different from having a red 1 and a blue 2. That's why this whole sample space right here has things that look like maybe they're repeating or something. Okay, it's because 1 and 2 is different from 2 and 1 because the different colors of the dice. So it's 2 different dice. So what's the probability of rolling an 8? Okay, well, you know how you play games is after you roll it, then you add them together. If I'd had the 2 and the 6, or the 3 and the 5, or the 4 and the 4, or the 5 and the 3, or the 6 and the 2, those add up to 8. So if I got any of those things when I'm looking at the dice after they're rolled, a red 6 and a blue 2, a red 5 and a blue 3, any of those, I'd have gotten 8. Okay, so if I'm hoping for an 8, those are them. 5 of them, those are good for me. And the sample space is, well, 6 by 6 is 36. So that's how you do that problem.